Okay, girls, for those who just enter, never mind, I write here. Okay, girls. Okay, copy this down as notes number 5. Okay, then try to solve it. Okay, done. So your initial volume is 20 liter. Okay, then the initial pressure is 1 atmosphere. Okay, then it expands to a volume which is 120 liter. Then they ask you what is the pressure at this altitude. So what you need to do is, okay, what you need to do is you put this into the formula, okay, which is P1 equals to P2 V2. Okay, P1 V1 equals to P2 V2. Okay, so your P1 it will be 1 atmosphere. Okay, you no need to do any conversion of the unit because the unit they have give you is the same. So which means that your final answer for your pressure it will be in ATM. Okay, ATM is one of the unit for your pressure. Okay, and so 1 times the V2 is V1 is 20. Okay, equals to P2, it will be P2 is the one that you want to find. Then your V2 is 120. Okay, so 20 equals to P2, 120. So P2 is equals to 20 divided by 120. So I think the answer, yes, correct, is 0.16 if I'm not mistaken. Wait, okay, correct. It will be 0.16 and the unit it will be ATM. Follow what they have given to you. Okay, follow what they have given to you. Okay, so this is the unit. Okay. You just round off into 2 decimal place will do. Okay, every time in physics, any answer given, you just give in 2 decimal place. Okay, 2 decimal place. Remember, yeah, sorry, 0.17. 0.17. 7 7 yes, must copy. Copy as notes number 5. Okay, clear? Okay, clear? How many of you now? 15. Oh yeah, good. I want to tell you all. Your class got how many of you? 22, right? 22. Okay. Every time, if let's say your class, every online classes, okay, 15, at least must have 15 students. Okay. If not, I won't send you the record video. Okay. 15 students, at least must be 15 students. So you please tell your friend to come to my online class. Okay. If not, I don't want to do online class already. You know, online class not very easy to do, you know. Okay? At least 15, Okay? Okay, any one of you want me to send? Hannah? At least 15, At least 15, okay? If let's say one day, less than 15, then I won't upload the video for you, Okay? So this one that I've sent it in your WhatsApp group is notes number 5. Notes number 5, Okay? Yes, HE is heat energy. Okay? Okay. So now I want you to try. Don't try this. And never mind, never mind. This one no need already. Okay, so now we have finished our first law already, which is Boyle's law. Now we will follow only for 15. Okay, then okay. Okay, so now we will move on to the pressure law and also Charles law. Okay, so pressure law and Charles law. Okay, wait a while. Okay, so for pressure law, it's talking about pressure and also absolute temperature. Okay, so what happened is, okay, I want to tell you about, just now I want to tell you, Suho Bunny, never mind already lah. You let me explain here lah. You listen to me better. Okay, okay, so for pressure law, okay, is explaining the relationship between pressure and also absolute temperature. Okay, so when we're talking about temperature, what we need to say? When temperature increase, heat energy also will increase. When heat energy increase, so what will increase as well? Yes, average kinetic energy. Okay, average kinetic energy also increase. Okay, as you know, kinetic energy is for the gas molecule to move about. Okay, so when it gain more average kinetic energy, so the gas molecule, it will move faster. Correct. Okay. So which again, I explain it in terms of temperature. Okay. When temperature increase, okay, when temperature increase, heat energy also will increase. So average kinetic energy also will increase. So this causes the gas molecule to move faster. Then why is it related to pressure? When you move faster, the it collide with what? With the wall of the container more frequently. More frequently. That's why the pressure will increase. The pressure will increase. Okay, moyang gaga. Let's see. Temperature increase, heat energy increase. Carry, okay. Gas move faster, collide more frequently. Very good. So moyang gaga. I don't know who is it. Moyang gaga is the correct, okay, the correct explanation, okay, about pressure law. So if let's say you want to talk about pressure law, you must talk about this whole thing. Okay? Can I? Okay. Any problem here? Okay, so pressure law is explaining the relationship between the pressure and the temperature. Temperature. Okay, so this is how you need to explain law in the pressure law. Gas is heated, temperature increases. So the heat energy also increases, causing the average kinetic energy. Remember, you must write down these important words for pressure law. Average kinetic energy increases. Average kinetic energy. So causes the faster moving molecule hits the wall more frequently. So it will resulting in a higher pressure. Higher pressure. Okay? Can I? So by the way, pressure law is talking about pressure and absolute temperature. So what is kept constant? What is kept constant? Correct. Volume or the mass of the gas. Okay. Moyang nenek pula. Moyang gaga and iklima. Please remember, you must write down mass of gas. Okay. Not only mass. Okay. Correct. Remember molecule. So this will be almost number 6. Pressure law. The definition of pressure law. Pressure is directly proportional to its absolute temperature. Remember, you must have the temperature measured in moyang nenek. You must measure in what? Wait, where? I'm too fast already, is it? I'm so sorry. Kelvin, correct. So when the volume is kept constant. So this is the symbol to explain about the relationship, okay, of the pressure law. Okay, pressure law. So this whole thing you must copy it down. This whole thing you must copy it down. Okay, so let us come to the graph. Okay, please look at the graph there. So graph same also is a graph to represent the pressure law. Okay, so if let's say it's a pressure and you see the temperature here is measured in what? In Kelvin. So that's why you will get a straight line graph passing through the origin, passes through the origin. But if let's say the temperature is measured in degrees Celsius, okay, as you know, if let's say my Kelvin wants to, my degrees Celsius, wait, let me erase it first, okay, my degrees Celsius, my God, why? My degrees Celsius wants to change it into Kelvin, I must add what? Yes, correct. Plus 273. Okay, so in another words, okay, 0 Kelvin. Okay, it's not okay, it's 0 Kelvin. 0 Kelvin is equivalent to negative 273 degree Celsius. Okay, is equals to negative 273 degrees Celsius. So you see here over here, okay, it will start with negative 273 degrees Celsius because that is the 0 Kelvin. So you can see that the graph is increasing, but it doesn't increase passing through the origin, but it passes like a linear graph. Okay, it's a linear straight linear graph lah. Okay, if let's say the question, the answer is measured, the temperature is measured in degrees Celsius, you won't get a graph passes through the origin. Okay, and also when it cuts the x-axis, okay, the the temperature is actually negative 273 degrees Celsius. Okay, can so if let's say it's P over T, P over T for your y-axis, then your x-axis is either T or pressure, then you will get a straight line graph already. Okay, and this formula is the formula that is used to calculate something that is related to pressure law. So which is P1 over T1 equals to P2 over T2. Okay, P1 over T1 equals to P2 over T2. So this is the notes number 6. Notes number 6. Okay, you want me to send in your WhatsApp group, or you want to copy it now? Send, okay. Please do my notes, okay. I go back when the school reopen. I see a lot of you didn't do. I want to sakai you already. I tell you, okay. Okay, so please take note on the Kelvin and the degree Celsius. Absolute, the straight line graph passes through the origin will only available when the temperature is measured in Kelvin. When the temperature is measured in Kelvin. Okay? Can Sakai. Sakai is knock your head. But not really knock your head on that. Okay? Can Okay, so this is the okay, so this is what I have told you just now. Okay, the temperature pressure becomes 0 at negative 273 degrees Celsius. Why? Because 0 Kelvin is negative 273 is equivalent to negative 273 degree Celsius. Okay, and the temperature measured on Kelvin is called absolute temperature. That's why for pressure law, we must make sure that the temperature is always measured in Kelvin, then only it applies pressure law. Okay? Any problem? No problem? Very good. Okay? So now, okay, this will be your notes number. Mama! Mama! Wait, Okay, this will be your notes number 7. We will do one example using the formula we have learned just now, which is the pressure law formula. Okay, so you copy this whole thing down. I will give you around 5 minutes to try it out. Okay, let me go down a while first. Okay, 5 minutes Đây, cho bên. Đưa cho xuống. Ayo, get here. Quay nói. Ồ, sofa sẵn như vậy. P1 T0 T1 E. Okay, I want the temperature measured in degree Celsius degree Celsius
Teacher, I susah payah go change in Kelvin.
Oh, but you are correct you must change it into Kelvin first Why? Because in the pressure law you must use temperature measured in Kelvin. Then only you will get the correct answer. P1 over T1.
Laundry woman này à?
Laundry woman我啲架車冇冇臭臭嘅。好啦，而家係幾多錢？
呢自己全嚟看面。
來 I'm here 周周喂老媽幫我關門 sorry OK 來 let's start now
你出還是進？
來這邊來接我來 OK so first we already know that our first temperature P1 is okay P1 is equals to 200 okay 200 kilopascal okay remember pascal also is one of the unit that measure the pressure okay then the temperature is 27 but please don't forget we must have the temperature measured in Kelvin so 27 must be plus 273 equals to 300 Kelvin okay you imagine Kelvin is your boyfriend every time you must add it in okay can then P2 is equals to 240 kilopascal. You see, the unit given is the same, so you don't need to do anything already. T2 is the one that you want to find. So you put into the formula. Okay, I write over here the formula. P1 over T1 equals to P2 over T2. So P1 is 200. Then your T1 is 300. Then your P2, 240. Then your T2 is the one you want to find. After that, you cross multiply. It will be T2 200 equals to 300 times 240. Then your T2 equals to 300 times 240 divided by 200. So what is the answer? Wait. So it's 360, it will be in Kelvin. But if let's say the question asks you to find in degrees Celsius, so what you need to do is 360 minus 273. So it will be correct. It's 87 degrees Celsius. Okay, everyone can get it? Sorry, a little bit blur here, blur there. Yes, Emily? For every question like that. Yes, we have to change it back to Celsius. Depends on the question. If the question give you the option in degrees Celsius, yes, you must change back to degrees Celsius. If not, you just remain it as Kelvin. If let's say it's a structure question, okay, structure question, you just remain it as Kelvin can already. But from what I have experienced with your senior, a lot of them forgot to add in the 273. Okay, if let's say they want to solve this problem, that's why they will get a wrong answer. So what here I want you to focus on, you must remember the temperature for pressure law must be in absolute temperature. So which means that you must change it into Kelvin. Okay? Any problem? No problem, Very good. So now we come to the last part of our class already. What time is it now? I know 4 o'clock you got MS. Oh, 15 minutes enough. Okay, why no? Suobani, who are you? Hey, Nene, Moyang Gaga, go back already. Moyang Gaga, go back already. Moyang Gaga sleep already. So sad. Okay, Lai. So come, we will go to the last part already. Last part of the law, which is Charles' law. Okay, Charles' law. Charles' law is a relationship. No, I just want you to come here and listen to my class only. Okay? Okay? So we go to Charles' law. Okay, Charles' law is a law explaining the relationship between volume and also temperature. So you see here, okay, these two, one has a lower temperature. This one has a higher temperature. Okay, as you know, when the temperature increase, then the heat energy will increase as well. Heat energy increase, the molecule will have a greater. Yes, why, Lady Gaga? Okay, wait. You see that you disturbed me already. Okay, the gas molecule will gain more average kinetic energy, so it will move faster. It will move faster already. It will collide more frequent to the wall of the container. Okay, so it will cause the increase in pressure. But please don't forget, for Charles' law, what is kept constant? For Charles' law, pressure is kept constant. Pressure is kept constant. So in order to maintain the pressure and at a constant level, so you must increase in the volume so that the pressure will become reduced back. Okay? Can no problem So this is Charles' law. So you see here, the gas is heated, average kinetic energy of the molecule increases. So the temperature also increases. If the gas is allowed to expand, the faster molecule now move at a bigger space. So bigger space already, the rate of the collision between the molecule and the wall will remain constant. So thus the pressure is constant. Okay, so this is pressure at Charles' law. Charles' law means that temperature increase, volume also increase. Okay, increase. Okay, but please remember your temperature here, you must use what temperature? Use what temperature? Not Kelvin, it's absolute temperature, which is measured in Kelvin. Okay? Okay, good. So this will be your notes number. Never mind, it's okay. You are learning. Notes number 8. Notes number 8 already, right? This one? Okay, so notes number 8 is the Charles' law. The Charles' law definition states that the volume of a fixed mass of gas is directly proportional to the absolute temperature. Absolute temperature when the pressure is kept constant. So this is the symbol to represent the volume and the temperature relationship. So this is the graph. Okay, as you can see, same also with what we have seen just now in the pressure law. You see in Kelvin, when the temperature measured in Kelvin, you will get a straight line graph passes through the origin. Okay, if let's say it's in degrees Celsius, so it will passes through like this. Then start at the negative 273 degrees Celsius. Okay, because this is where 0 Kelvin is. Okay, then if let's say your x-axis and y-axis is either T or pressure, okay, then your y-axis is, this one is not T or P, it should be V. Wait, I erase it first. Okay, this one, again, please take note now. This one should be V. V, okay, then V over T as your y-axis, then you will get a straight line graph passing through the origin. Okay, all of them is V. No, only this part is V. This one is T. This one is V. Okay, then the formula it will be V1 over T1 equals to V2 over T2. Okay, so again, same. You want me to, no need already lah. Okay, this is number 8, number 6, 5. This one is 5, huh? Emily, yes, that one in your WhatsApp group, yes, that one, this one, is number 5. It's the one before that. Okay, number 7, sorry, I didn't, I just now forgot it already. Anyone can share on the WhatsApp group, you all can do so lah, huh? Okay, can I move on? Because we still have 7 minutes left. Can I? Good. Okay, now. Okay, so this one, I want you to copy one of it, which means that this one as your number 9. Okay, number 9. Okay, please copy this as notes number 9. Then I want you to try it out using the formula V1 over T1 equals to V2 over T2 to get the answer. Okay, try now. Hey, 小傻，哦，不是，你不要给我助攻，不要给我助攻，不要给我助攻，我助攻上，你没有机会给我助攻，你知道吗？以后我就学你会的助攻，嗯 ，OK， OK。来，小傻。360 V1 来，过来。来啦。Now we are talking about the volume, right? So we will use V1 over T1 equals to V2 over T2. Okay? Okay, then your V1 is 180. T1 is what? 27 plus 273 is 300. Okay? Then your V2, you don't know about it. Then your T2 is 54 plus 273. It will be 327. Everything you must add the temperature 273 and change it into Kelvin. So 180 divided by T1 is 300 equals to V2 over 327. Now, so V2 equals to 180 times 327 divided by 300 times 180除以300. What is your answer? Let me see. Suhobani. Suhobani Y. Iklima. Iklima. Semua sudah betul. Okay, so this is it. Okay, Moya Nene also betul. Okay, so the answer is 196.2 cm cubed. So it's you must remember everything. You must change it into Kelvin. Then only you can do the correct answer. Okay? Can? Any problem here? Very good. Okay, so now, okay, this is a summary. Okay, I want you to try to this one is not number 10. Okay, it's a summary of what we have learned about gas law. Okay, we have Boyle's law, okay, pressure law, okay. I let you give you some time to, and never mind, I don't want to give you some time already. Like we do it together now. Then I will write the answer over here. So what I will do is I will snap a photo, then I will put inside the WhatsApp group. Later on you check yourself. Okay? Note number 10. Okay, so now like okay, please bear with my never mind. Okay. So what is A? So A is about Boyle's law, temperature, pressure. So the responding variable is, yeah, so please faster, What is it? No. Temperature is the fixed variable. Then your manipulator is pressure, volume is the, yes, correct, volume. Okay, it can be either volume or it can be either pressure as the responding variable as well. So the relationship is what? What is the relationship? This is what? You want to know this one is relationship is inversely proportional, but every time we use what to talk about inversely proportional, P is correct, 1 over V. Okay, 1 over V. Very good. So what is the formula we are using? Just now I see someone write the answer already. Iklima. Okay. What is the C? C, but C. Correct. Emily, correct. Yes. P1, okay, V1 equals to P2, V2. Okay, very good. So pressure law. What is your fixed variable here? Pressure law, what is the fixed variable? Pressure is talking about pressure and absolute temperature. So what is the correct volume? Okay, so I think volume. Okay, so what is the manipulator variable? Can, mass of the gas and volume also can, but here we talk about volume lah, huh? Okay, temperature, but you must talk about what? Absolute temperature. Okay, you must talk about absolute temperature. So pressure is here. What is the relationship? Pressure is directly proportional to the what? Temperature. Wait. Less than 1 minute only. Faster. Okay. G. What is G? What is G? Charles law. Okay, Charles law, pressure, absolute temperature. So the responding variable is volume. Okay, Suhobani correct. Volume. Okay, so mama, then the formula will be V1 over T1 equals to V2 over T2. Very good. Clap your hand. Okay. He didn't stop it yet. Okay, never mind. Okay, so now we have already. No, don't have time already. Later I will copy this out. Okay, so